Hi friends and friends, welcome to my YouTube channels. So today we are going to start the problem for the impact of collision. Before video, already we discussed the formula and basic concept and basic terms of this related topic, impact of collision. So I taken today one problem. This is second video for this impact of collision. So what is the given data there? First we'll collect, then we'll explain parallelly with the problems. Okay, block A mass they given 2 kg. Moving at velocity they given 10 meter per second. Collide with the another block. So parallelly we draw one diagram also. Block A. This is block A. Block B. So mass they given, M1 they given 2 kg, V1 they given 10 meter per second. M2 they given 6 kg, 6 kg and V1 they given V2 they given 4 meter per second. Now read the block A of mass 2 kg moving at 10 meter per second velocity V1 with another block B 6 kg but in same directions. So going the same directions means give the directions is same. Both C1, C2 the mass center. So both the same directions, moving with the same direction. So velocity also will be the plus. Velocity V1, V2 will be the plus. If the collision is perfectly elastic. If collision is perfectly elastic, that means coefficient of restitution. Coefficient of restitution. Coefficient of restitution will be 1. Coefficient of restitutions will be 1. So coefficient of restitutions will be 1 for elastic body. Now how to solve this? They are asking find the velocity after impact. So V1 dash and V2 dash what we want. They are asking this question. This is the question they are asking. So already you know two formula we can utilize. Conservation of mass moment and coefficient of restitution. So we'll write the law of conservation of or applying the law of conservation of momentum. Applying laws of conservation, law of conservation of momentum principle. So what is this one? M1 V1 plus M2 V2 before collision. After collision, M1 V1 dash plus M2 V2 dash. Law of conservation. Substitute all the value here. Mass is 2, velocity is 10 plus mass is 6 into velocity is 4 equal to mass M1 is 2, V1 dash we have to find out mass 6 into V2 40, V2 dash we have to find out. So what is 20 plus 24 is equal to, you take 2 common, what will come? V1 dash plus 3 V2 dash. Now 44 and then 2 cancel. So what will come? I'll write one more step. So okay, 44 by divide 2 V1 dash plus 3 V2 dash. So finally what we'll get here? V1 dash plus 3 V2 dash equal to 22. Give equations number 1. So one equations we know now. We know the first equations. Now coefficient of restitutions, what is formula? E is equal to formula is there. V2 dash minus V1 dash divided by V1 minus V2. So what is this one? It is the ratio of what is relative velocity of approach, relative velocity of separations by relative velocity of approach. This is relative velocity of separation after impact, relative velocity of approach. So E is equal to 1 given. Why? Because the given body is perfectly elastic. E is equal to 1. So what is there? V2 dash minus V1 dash by V1 minus V2. So what is V1 here? 10 minus 4. So 6. So that implies we will get here V2 dash V1 dash equal to 6. Give equations number 2. V2 dash V1 dash equal to 6, equation 2. We'll solve now. From equation 1 and 2. From equation 1 and 2. What is equations 1? This one. V1 dash. So right here 3V2 dash plus V1 dash equal to 22. Because I wrote V2 here because here V2 plus is there. So always we'll solve na. For our convenience we'll write like this. Minus V1 dash equal to 6. Okay. V2 dash. This is V1 dash. V2 dash. Now how to solve? Multiply 1, multiply 3. So what will get the new equations? New equations will get 3V2 dash plus V1 dash equal to 22. And then this will get 3V2 dash minus 3V1 dash equal to 18. We got this. So okay, these equations will bring here. V2 dash minus V1 dash equal to 6, equations 2 bring here. So we'll solve this question. Now, what is the rule to solve? Second equation C, plus, so minus, plus, change the sign opposite, no? So minus, what is this get cancelled? This plus, 4V1 dash equal to 4. So V1 dash equal to nothing but 1 meter per second plus, so directions will be this only. Now what you do? Substitute this V1 in equation 1 or 2, anywhere, 1 or 2. So equations 2 is simple. So what we'll do here? Substitute V1 in equation 1. Substitute V1 dash in equation 2. So because 2 is small, anywhere you can substitute. V2 dash minus V1 dash equal to 6. So V2 dash equal to 6, this minus 1. So it will come plus 1 equal to 7 meter per second. So V2 dash we are getting 7 meter per second. So this they are asking. How you will check that? If you conservation of mass momentum equations, if you substitute here m1 v1 plus m2 v2, you will get equal this. So you want to check now, just will check this time. This will check now. So this is the answer. This we got the answer now. V1. So V1, V2 dash. This is also plus. So this is the directions. V1 dash equal to 1 meter per second. This is the directions here. So we know. Now we will substitute here. M1 how much? So this already how much? 44. This side you have to check. M1 how much? 2. 2 into what is V1 dash? 1 plus M2. M2 nothing but 6. M2 nothing but 6 into how much you got? V2 dash? 7. So 2 plus 42. How much coming? 44. So this is equal. So laws of conservation of momentum, once you are substituting these two value, you are getting the equal. But this is our, these two will be our answer. So this way we can solve the, our whatever problems they will give conservation of momentum for impact of collision problems, we can solve this way. Okay. Watch video students and subscribe the channels and give the feedback. Okay. Thank you.